Undoubtedly, data science is the most in-demand technology of the era. It is all about finding useful insights in order to solve complex problems and to grow a business. Hi everyone, I welcome you to this session on data science tutorial that contains everything that you need to know in order to get started with data science. Now before we move any further, let's take a look at the agenda for today. We're going to start this session by understanding the need for data science. Here we'll discuss how the evolution of data and technology has led to the need for data science. Next, we'll move on and see how Walmart uses data science in order to grow their business. After that, we'll discuss what exactly data science is, and we'll see who a data scientist is and the different skills required to become a data scientist. Next, we'll discuss the different data science job roles. Here we'll talk about data analysts, data engineers, statisticians, and so on. Finally, we'll move on and look at data lifecycle, where we'll understand how data can be extracted, processed, and used as a solution. Next, we'll look at introduction to machine learning, where we'll understand what exactly machine learning is and the different types of machine learning. Once we're done with that, we'll move on and discuss the K-means algorithm, and we'll understand how it works with the help of a use case. After that, we'll see how to implement K-means and see how you can cluster different movies based on their reviews. Finally, we'll end this session by looking at the data science certification course offered by Edureka and why you should take it up. Now, before we get started, make sure you subscribe to Edureka YouTube channel in order to stay updated about the most trending technologies. Do you guys remember the times when we had telephones and we had to go to PCO booths in order to make a phone call? Now, those times were very simple because we didn't generate a lot of data. But these days we have smartphones which store a lot of data. So there's everything about us in our mobile phones. Similarly, the PCs that we use in the earlier times, it used to process very little data, alright? There was not a lot of data processing needed because technology wasn't evolved that much. So if you guys remember, we used floppy disks back then, and floppy disk was used to store small amounts of data. But later on, hard disks were created and those used to store GBs of data. But now if you look around, there's data everywhere around us. Alright, we have data stored in the cloud, we have data in each and every appliance at our houses. Similarly, if you look at smart cars these days, they're connected to the internet, they're connected to our mobile phones, and this also generates a lot of data. In order to process this much data, we need more complex algorithms, we need a better process. Alright, and this is where data science comes in. Now, IoT or Internet of Things is just a fancy term that we use for network of tools or devices that communicate and transfer data through the internet. Guys, IoT data is measured in zettabytes, and 1 zettabyte is equal to trillion gigabytes. So according to a recent survey by Cisco, it's estimated that by the end of 2019, which is almost here, the IoT will generate more than 500 zettabytes of data per year. Moving on, let's see how social media is adding on to the generation of data. Now, the fact that we are all in love with social media, it's actually generating a lot of data for us. Okay, it's certainly one of the fuels for data creation. Now, all these numbers that you see on the screen are generated every minute of the day. Now, guys, apart from social media and IoT, there are other factors as well which contribute to data generation. These days, all our transactions are done online. Right, we pay bills online, we shop online, we even buy homes online these days. You can even sell your pets on OLX these days. Not only that, when we stream music and we watch videos on YouTube, all of this is generating a lot of data. So with the emergence of the internet, we now perform all our activities online. Okay, obviously this is helping us, but we are unaware of how much data we are generating. What can be done with all of this data, and what if we could use the data that we generated to our benefit? Well, that's exactly what data science does. Data science is all about extracting the useful insights from data and using it to grow your business. Now, before we get into the details of data science, let's see how Walmart uses data science to grow their business. So guys, Walmart is the world's biggest retailer with over 20,000 stores in just 28 countries. Okay, now it's currently building the world's biggest private cloud, which will be able to process 2.5 petabytes of data every hour. Now, the reason behind Walmart's success is how they use the customer data to get useful insights about customers' shopping patterns. Now, the data analysts and the data scientists at Walmart, they know every detail about their customers. They know that if a customer buys Pop-Tarts, they might also buy cookies. How do they know all of this? Like, how do they generate information like this? Now, they use the data that they get from their customers and they analyze it to see what a particular customer is looking for. Now, let's look at a few cases where Walmart actually analyzed the data and they figured out the customer needs. So, let's consider the Halloween and the cookie sales example. Now, during Halloween, sales analyst at Walmart took a look at the data, okay, and he found out that a specific cookie was popular across all Walmart stores. So, every Walmart store was selling these cookies very well. But he found out that there were 2 stores which were not selling them at all. Okay, so the situation was immediately investigated and it was found that there was a simple stocking oversight, okay, because of which the cookies were not put on the shelves for sale. So because this issue was immediately identified, they prevented any further loss of sales. Now, another such example is that through association rule mining, Walmart found out that strawberry Pop-Tart sales increased by 7 times before a hurricane. So a data analyst at Walmart identified the association between hurricane and strawberry Pop-Tarts through data mining. Now guys, don't ask me the relationship between Pop-Tarts and hurricane, but for some reason, whenever there was a hurricane approaching, people really wanted to eat strawberry Pop-Tarts. So what Walmart did was they placed all the strawberry Pop-Tarts at the checkouts before a hurricane would occur. So this way they increase sales of their Pop-Tarts. Now guys, this is an actual thing. I'm not making it up. You can look it up on the internet. Not only that, Walmart is analyzing the data generated by social media to find out all the trending products. So through social media, you can find out the likes and dislikes of a person, right? So what Walmart did is they're quite smart. They use the data generated by social media to find out what products are trending or what products are liked by customers. Okay, an example of this is Walmart analyzed social media data to find out that Facebook users were crazy about cake pops. Okay, so Walmart immediately took a decision and they introduced cake pops into the Walmart stores. So guys, the only reason Walmart is so successful is because the huge amount of data that they get, they don't see it as a burden. Instead, they process this data, analyze it, and then they try to draw useful insights from it. Okay, so they invest a lot of money, a lot of effort, and a lot of time in data analysis. Okay, they spend a lot of time analyzing data in order to find any hidden patterns. So as soon as they find out hidden pattern or association between any 2 products, they start giving out offers or they start giving discounts or something along that line. So basically, Walmart uses data in a very effective manner. They analyze it very well, they process the data very well, and they find out the useful insights that they need in order to get more customers or in order to improve their business. So guys, this was all about how Walmart uses data science. Now let's move ahead and look at what is data science. Now guys, data science is all about uncovering findings from data. It's all about surfacing the hidden insights that can help companies to make smart business decisions. So all these hidden insights or these hidden patterns can be used to make better decisions in a business. Now, an example of this is also Netflix. So Netflix basically analyzes the movie viewing patterns of users to understand what drives user interest and to see what users want to watch. And then once they find out, they give people what they want. So guys, actually data has a lot of power. You should just know how to process this data and how to extract the useful information from data. Okay, that's what data science is all about. So guys, a big question over here is how do data scientists get useful insights from data? So it all starts with data exploration. Whenever a data scientist comes across any challenging question or any sort of challenging situation, they become detectives. So they investigate leads and they try to understand the different patterns or the different characteristics of the data. Okay, they try to get all the information that they can from the data, and then they use it for the betterment of the organization or the business. Now let's look at who is a data scientist. So guys, a data scientist has to be able to view data through a quantitative lens. So guys, knowing math is one of the very important skills of a data scientist. Okay, so mathematics is important because in order to find a solution, you're going to build a lot of predictive models. And these predictive models are going to be based on hard math. So you have to be able to understand all the underlying mechanics of these models. Most of the predictive models, most of the algorithms require mathematics. Now, there's a major misconception that data science is all about statistics. Now, I'm not saying that statistics isn't important. It is very important, but it's not the only type of math that is utilized in data science. There are actually many machine learning algorithms which are based on linear algebra.
So guys, overall, you need to have a good understanding of math. And apart from that, data scientists utilize technology. So data scientists have to be really good with technology. Okay, so their main work is they utilize all the technology so that they can analyze these enormous data sets and work with complex algorithms. So all of this requires tools which are much more sophisticated than Excel. So guys, data scientists need to be very efficient with coding languages, and few of the core languages associated with data science include SQL, Python, R, and SAS. It is also important for a data scientist to be a tactical business consultant. So guys, business problems can be only solved by data scientists. Since data scientists work so closely with data, they know everything about the business. If you have a business and you give the entire data set of your business to a data scientist, he'll know each and every aspect of your business. Okay, that's how data scientists work. They get the entire data set, they study the data set, they analyze it, and then they see where things are going wrong or what needs to be done more or what needs to be excluded. So guys, having this business acumen is just as important as having skills in algorithms or being good with math and technology. So guys, business is also as important as these other fields. Now you know who a data scientist is. Let's look at the skill sets that a data scientist needs. Okay, it always starts with statistics. Statistics will give you the numbers from the data. So a good understanding of statistics is very important for becoming a data scientist. You have to be familiar with statistical tests, distributions, maximum likelihood, estimators, and all of that. Apart from that, you should also have a good understanding of probability theory and descriptive statistics. These concepts will help you make better business decisions. So no matter what type of company or role you're interviewing for, you're going to be expected to know how to use the tools of the trade. Okay, this means that you have to know a statistical programming language like R or Python. And also you'll need to know a database querying language like SQL. Now the main reason why people prefer R and Python is because of the number of packages that these languages have. And these predefined packages have most of the algorithms in them. So you don't have to actually sit down and code the algorithms. Instead, you can just load one of these packages from their libraries and run it. So programming languages is a must. At the minimum, you should know R or Python and a database querying language. Now let's move on to data extraction and processing. So guys, suppose that you have multiple data sources like MySQL database, Mongo database. Okay, so what you have to do is you have to extract from such sources, and then in order to analyze and query this database, you have to store it in a proper format or a proper structure. Okay, finally, then you can load the data in the data warehouse and you can analyze the data over here. Okay, so this entire process is called extraction and processing. So guys, extraction and processing is all about getting data from these different data sources and then putting it in a format so that you can analyze it. Now next is data wrangling and exploration. Now guys, data wrangling is one of the most difficult tasks in data science. This is the most time consuming task because data wrangling is all about cleaning the data. There are a lot of instances where the data sets have missing values, or they have null values, or they have inconsistent formats or inconsistent values. Now you need to understand what to do with such values. This is where data wrangling or data cleaning comes into the picture. Then after you're done with that, you are going to analyze the data. So guys, after data wrangling and cleaning is done, you're going to start exploring. This is where you try to make sense out of the data. Okay, so you can do this by looking at the different patterns in the data, the different trends, outliers, and various unexpected results and all of that. Next, we have machine learning. So guys, if you're a large company with huge amounts of data, or if you're working at a company where the product is data driven, like if you're working in Netflix or Google Maps, then you have to be familiar with machine learning methods. All right, you cannot process large amount of data with traditional methods. So that's why you need machine learning algorithms. So there are a few algorithms like KNN or K-nearest neighbor. There's random forest, there's K-means algorithm, there's support vector machines. All of these algorithms, you have to be aware of all of these algorithms. And let me tell you that most of these algorithms can be implemented using R or Python libraries. Okay, you need to have an understanding of machine learning if you have large amount of data in front of you, which is going to be the case for most of the people right now because data is being generated at an unstoppable pace. Earlier in the session, we discussed how much of data is generated. So for now, knowing machine learning algorithms and machine learning concepts is a very required skill if you want to become a data scientist. So if you're sitting for an interview as a data scientist, you will be asked machine learning algorithms. You will be asked how good you are with these algorithms and how well you can implement them. Next, we have big data processing frameworks. So guys, we know that we've been generating a lot of data, and most of this data can be structured or unstructured as well. So on such data, you cannot use traditional data processing system. So that's why you need to know frameworks like Hadoop and Spark. Okay, these frameworks can be used to handle big data. Lastly, we have data visualization. So guys, data visualization is one of the most important part of data analysis. It is always very important to present the data in an understandable and visually appealing format. So data visualization is one of the skills that data scientists have to master. Okay, if you want to communicate the data with the end users in a better way, then data visualization is a must. So guys, there are a lot of tools which can be used for data visualization. Tools like Tableau and Power BI are few of the most popular visualization tools. So with this, we sum up the entire skill set that is needed to become a data scientist. Apart from this, you should also have data-driven problem-solving approach. You should also be very creative with data. So now that we know the skills that are needed to become a data scientist, let's look at the different job roles. Since data science is a very vast field, there are many job roles under data science. So let's take a look at each role. Let's start off with a data scientist. So guys, data scientists have to understand the challenges of a business, and they have to offer the best solution using data analysis and data processing. So for instance, if they are expected to perform predictive analysis, they should also be able to identify trends and patterns that can help the companies in making better decisions. To become a data scientist, you have to be an expert in R, MATLAB, SQL, Python, and other complementary technologies. It can also help if you have a higher degree in mathematics or computer engineering. Next, we have data analysts. So a data analyst is responsible for a variety of tasks, including visualization, processing of massive amount of data, and munging. They have to also perform queries on databases, so they should be aware of the different querying languages. And guys, one of the most important skills of a data analyst is optimization. This is because they have to create and modify algorithms that can be used to pull information from some of the biggest databases without corrupting the data. So to become a data analyst, you must know technologies such as SQL, R, SAS, and Python. So certification in any of these technologies can boost your job application. You should also have a good problem-solving quality. Next, we have a data architect. So a data architect creates the blueprints for a data management so that the databases can be easily integrated, centralized, and protected with the best security measures. Okay, they also ensure that the data engineers have the best tools and systems to work with. So to become a data architect, you have to have expertise in data warehousing, data modeling, extraction, transformation, and loan. Okay, you should also be well versed in Hive, Pig, and Spark. Now, apart from this, there are data engineers. So guys, the main responsibility of a data engineer is to build and test scalable big data ecosystems. Okay, they are also needed to update the existing systems with newer or upgraded versions, and they are also responsible for improving the efficiency of a database. Now, if you're interested in a career as a data engineer, then technologies that require hands-on experience include Hive, NoSQL, R, Ruby, Java, C++, and MATLAB. It would also help if you can work with popular data APIs and ETL tools. Next, we have a statistician. So as the name suggests, you have to have a sound understanding of statistical theories and data organization. Not only do they extract and offer valuable insights, they also create new methodologies for engineers to apply. Now, if you want to become a statistician, then you have to have a passion for logic. There are also good variety of database systems such as SQL, data mining, and other various machine learning technologies. By that, I mean you should be good with math, and you should also have a good knowledge about the various database systems such as SQL, and also the various machine learning concepts and algorithms is a must. Next, we have the database administrator. So guys, the job profile of a database administrator is pretty much self-explanatory. They are basically responsible for the proper functioning of all the databases, and they are also responsible for granting permission or revoking its services to the employees of the company. they also have to take care of the database backups and recoveries. So some of the skills that are needed to become a database administrator include database backup and recovery, data security, data modeling, and design. Next, we have the business analyst. Now, the role of a business analyst is a little bit different from all of the other data science jobs. Now, don't get me wrong, they have a very good understanding of the data-oriented technologies. They know how to handle a lot of data and process it, but they are also very focused on how this data can be linked to actionable business insights. So they mainly focus on business growth. Okay, now a business analyst acts like a link between the data engineers and the management executives. So in order to become a business analyst, you have to have an understanding of business finances, business intelligence, and also IT technologies like data modeling, data visualization tools, and etc. At last, we have a data and analytics manager. A data and analytics manager is responsible for the data science operations. Now, the main responsibility of a data and analytics manager is to oversee the data science operation. Okay, he's responsible for assigning the duties to the team according to their skills and expertise. Now, their strengths should include technologies like SAS, R, SQL, and of course, they should have good management skills. Apart from that, they must have excellent social skills, leadership qualities, and an out-of-the-box thinking attitude. And like I said earlier, you need to have a good understanding of technologies like Python, SAS, R, Java, and etc. So guys, these were the different job roles in data science. I hope you all found this informative. Now let's move ahead and look at the data lifecycle. So guys, there are basically 6 steps in the data lifecycle. It starts with a business requirement. Next is the data acquisition. After that, you'll process the data, which is called data processing. Then there is data exploration, modeling, and finally deployment. So guys, before you even start on a data science project, it is important that you understand the problem you're trying to solve. So in this stage, you're just going to focus on identifying the central objectives of the project, and you'll do this by identifying the variables that need to be predicted. Next up, we have data acquisition. Okay, so now that you have your objectives defined, it's time for you to start gathering the data. So data mining is the process of gathering your data from different sources. At this stage, some of the questions you can ask yourself is, what data do I need for my project? Where does it live? How can I obtain it? And what is the most efficient way to store and access all of it? Next up, there is data processing. Now, usually all the data that you collected is a huge mess. Okay, it's not formatted, it's not structured, it's not cleaned. So if you find any data set that is cleaned and it's packaged well for you, then you've actually won the lottery, because finding the right data takes a lot of time and it takes a lot of effort. And one of the major time consuming tasks in the data science process is data cleaning. Okay, this requires a lot of time, it requires a lot of effort, because you have to go through the entire data set to find out any missing values, or if there are any inconsistent values or corrupted data. And you also find the unnecessary data over here and you remove that data. So this was all about data processing. Next, we have data exploration. So now that you have sparkling clean set of data, you are finally ready to get started with your analysis. Okay, the data exploration stage is basically the brainstorming of data analysis. So in order to understand the patterns in your data, you can use histograms. You can just pull up a random subset of data and plot a histogram. You can even create interactive visualizations. This is the point where you dive deep into the data and you try to explore the different models that can be applied to your data. Next up, we have data modeling. So after processing the data, what you're going to do is you're going to carry out model training. Okay, now model training is basically about finding the model that answers the questions more accurately. So the process of model training involves a lot of steps. So firstly, you'll start by splitting the input data into the training data set and the testing data set. Okay, you're going to take the entire data set and you're going to separate it into 2 parts. One is the training and one is the testing data. After that, you'll build the model by using the training data set. And once you're done with that, you'll evaluate the training and the test data set. Now, to evaluate the training and testing data set, you'll be using series of machine learning algorithms. After that, you'll find out the model which is the most suitable for your business requirement. So this was mainly data modeling. Okay, this is where you build a model out of your training data set, and then you evaluate this model by using the testing data set. Next, we have deployment. So guys, the goal of this stage is to deploy the model into a production or maybe a production-like environment. So this is basically done for final user acceptance. and the users have to validate the performance of the models, and if there are any issues with the model or any issues with the algorithm, then they have to be fixed in this stage. So guys, with this we come to the end of the data life cycle. I hope this was clear. Now let's move ahead and look at machine learning. Okay, we'll see what machine learning is, and we'll also discuss the types of machine learning. So what is machine learning? Now machine learning is the science of getting computers to act by feeding them data and letting them learn a few tricks on their own. Okay, so here you're not going to actually program the machine to do something. Instead, you're going to feed a lot of data to the machine and you're going to let the machine learn on its own. This is what machine learning is. So guys, if you think of it, it's a lot like how we humans work. As children, we didn't really know what an apple was or an orange was until that data was fed to us. Okay, until we observed our surroundings and we noticed, oh, an apple looks red in color and it's round, and similarly an orange is orange in color and it's round. Okay, unless and until we didn't observe all of these things, we didn't actually understand. Now the process of observing is basically feeding data to your brain. That's exactly what you do to a machine. Okay, you feed a lot of data to a machine and then you let it learn on its own. So guys, this is what machine learning is. So as a child, if we were given apples and cherries and oranges, we'd probably think they were the same, because back then we didn't have a lot of data in our head. Okay, we didn't know how to process this much data. So guys, an example here is if you give images of cherry, apple and oranges to a machine and you ask it to distinguish between the three. In the first try, obviously it's not going to know what is cherry, what is an apple or what is an orange. But if you keep feeding it images of cherries, of apples and of oranges, and you tell it that, okay, listen, a cherry looks smaller and it's red in color. But if you keep feeding the machine a lot of data, it's going to analyze this data. Okay, it'll find a pattern. It'll say, okay, so cherries are smaller when compared to apples, apples are rounder and oranges are orange in color. So it's going to learn from the data, just like how we humans learn from observing our surroundings or taking an information from our surroundings. A machine is also going to learn from observing its surroundings. Okay, so guys, this is basically what machine learning is. In simple terms, you're just going to feed a lot of data to the machine. The machine is going to process this data, it's going to find hidden patterns in this data, and it's going to try to come out with a solution. Okay, this is what machine learning is. Now let's move ahead and look at the different types of machine learning. So first we have supervised learning. Supervise basically means to direct a certain activity and make sure it's done correctly. So guys, as kids, you remember that in classrooms we always needed a teacher to guide us. We couldn't solve a simple math problem on our own, but then when we got the guidance or we got help from our teachers, we would easily be able to solve it. So guys, this is exactly how supervised learning works. Okay, so you feed the model a set of data called the training data, which contains both the input data and the corresponding expected output. Okay, now the training data acts like a teacher and it teaches the model the correct output. So for a particular input, it will tell, okay, this is the output. So in supervised learning, every time you feed data to the machine, it's always labeled. Okay, so basically you're telling the machine, okay, so look, this is an apple and this should be the output. This is how apples look. Okay, that's supervised learning. So you basically have a teacher who's going to teach the machine. And the teacher here is basically the training data. Now let's look at what unsupervised learning is. So guys, unsupervised means to act without anyone's supervision or without anyone's direction. Okay, so when a child grows into an adult, he no longer needs someone to guide him at every step. Okay, so he observes and he learns without any help. This is exactly how unsupervised learning works. In unsupervised machine learning, the model is given a data set which is neither labeled nor classified. So basically the machine is just going to explore the data and it's going to draw its own inferences from the data and it's going to find hidden structures from this unlabeled data. But what unsupervised learning can't do is that it cannot add label clusters. Okay, so it cannot say, okay, listen, this is a group of cats or this is a group of dogs, but it will separate the cats from the dogs. Next, we have reinforcement learning. Now, reinforcement means to establish or to encourage a pattern of behavior. So guys, let's say that you were dropped off at an isolated island. Okay, what would you do? Now, initially, we'd all panic and you'd be unsure of what to do. You don't know where to get your food from. You don't know how to live and all of that. But after a few days, you will have to adapt. You have to learn how to live in the island. You have to adapt to the changing climate. You have to learn what to eat and what not to eat. So you're basically following the hit and trial concept. Okay, because you're new to the surrounding and the only way for you to learn is to experience. Okay, so you experience and then you learn from your experience. So this is what reinforcement learning is. It is a learning method wherein an agent interacts with its environment by producing actions and discovers errors or rewards. Here an agent is basically you stuck on the island and the environment is the island. So you're trying to live in the island by following the hit and trial concept. So guys, those were the types of machine learning. Now let's move ahead and look at a K-means use case. So it's needless to say that I've heard of hundreds of cases wherein people die due to undetected brain tumors. So guys, detection of brain tumors varies on the type of tumor and how advanced it is. One of the most effective ways of segmenting and detecting brain tumors is by implementing the K-means clustering method. So before we go any further, let's define K-means. So K-means is basically unsupervised learning algorithm which solves the well-known clustering problem. So basically you input a data set into the algorithm and you will tell the algorithm to cluster this data set into k number of clusters. Okay, so if I had to cluster some data into 3 clusters, then the value of k would be 3. Alright, so we'll be discussing the algorithm in depth in the upcoming slides. For now, let's see how K-means can detect brain tumors. So guys, basically you're going to input an MR image into the K-means algorithm and you're going to say, listen, cluster this image into 3 different colors. Okay, so if I want to cluster the image into black, gray and white, then my value of k is going to be 3. Okay, so what K-means will do is it will study each and every pixel and it will find out the RGB value. Through the RGB value, you can find out the color of each pixel. So it'll find out the color of each pixel and then it'll cluster different pixels depending on their intensities or depending on their color. Okay, it's up to you which feature you want K-means to choose in order to cluster the pixels. Okay, so here you can see in the first image that K-means is clustering this image into 3 parts. One is the black portion, one is the gray portion and the other is the white portion. Similarly, when you cluster this image into 2 parts or into 2 clusters, in this image you can see that the tumor area is highlighted. So the tumor area is clustered into white. Okay, this is because you're clustering it into 2 clusters. Okay, so you're asking K-means to classify it into the diseased and non-diseased part. The tumor part here is represented by the white area and the normal part or the non-diseased part is represented by the black color. So guys, this is how K-means is used in brain tumor detection. Now we're not going to go in too much depth with brain tumor detection because it involves a lot of image processing and computer vision, which is not in the scope of this session. So before we go any further, let's look at K-means algorithm step by step. Okay, so the first step in the K-means algorithm is to give the algorithm the value of k. Now before you run the algorithm, you need to decide how many clusters you need to create. So let's look at this example over here. There are a few data points which are scattered on this graph. So in this example, I know that I can approximately create 2 clusters since the data is quite small. I'll also be explaining how we choose the value of k, as in how we decide how many clusters we want. So I'll explain that in a bit. But yeah, for this example, we have 2 means, as in we'll have 2 clusters formed at the end of this algorithm. So once we have the value of k decided, like here I've said that I want to build 2 clusters. The second step in the algorithm would be to select 2 random points from the given data elements. Okay, and these selected points are called centroids. Now these elements marked as 1 and 2 are the randomly chosen centroid points. And each of these centroids form the representative point for their respective clusters. Though we don't know if these centroids are going to be the center or the mean of these 2 clusters, but once we iterate through the algorithm, it will converge at a point where these centroids will be the center of each cluster. Alright, so once I've assigned the centroids, the next step would be to calculate the distance between each data point and the 2 centroids, so that we can identify which data point is closest to cluster 1 and similarly which data point is closest to cluster number 2. Now even though I've assigned 2 colors, red and green, to denote the 2 clusters, this does not mean that all the red points belong to cluster 1 and all the green points belong to cluster number 2. This is just the first iteration, so we haven't actually calculated anything yet. Now after assigning the centroids, our next step is to compute the distance between each data point and the centroids, and if we find that some data point has a minimum distance from a centroid, then we add that data point into the cluster. And because of this, the mean of the cluster changes. Alright, and that's why the centroid moves. Now next, repeat the same thing. Since the centroids have moved based on how these new partitions have formed, we need to again classify and assign the clusters and then recompute the means. So again, the centroids will move depending on the new clusters. Alright, now this keeps happening until the centroids stop moving and changing the positions, which means that the centroids are now perfectly at the center of their respective clusters. Alright, so this is the end result, and you can see that cluster number 1 has the red points in it and cluster number 2 has the green points in it. Okay, these are the two clusters which are formed at the end. So guys, this is how K-means algorithm works. So now let's look at our demo, but before we start running the demo, let's look at the problem statement. We have this group of movies with information about each movie. Okay, what we're trying to do is we're going to group the movies into a set of clusters based on movies which are popular on social media. This could also mean movies which are good and have a good fan following. Okay, so let's jump into the demo. So guys, before I run the demo, I want to tell you that I'm going to be using the R language to run this demo. And it's quite understandable. I'm going to explain each line in depth. Okay, so don't worry if you don't know R at all, because this is very understandable. It's like English. And also, if you want to learn R in depth, then I'm going to leave a link in the description. You can watch that content and learn about R and then maybe come back to this. So let's see how to cluster a given set of movies based on the likes it gets. Okay, so this is our objective, and we're going to cluster the popular movies based on the Facebook likes. So guys, in order to save time, I've already typed out the code, but don't worry, I'm going to explain each line in depth. Now, let me show you the data set. Alright, so I'll be using the read.csv function over here. I'll be using this function to read the data set. Okay, now our data set is movie metadata.csv. Okay, it's stored in a comma separated file, and this is basically the path to my data set. So let me run this. Now over here, I'll be removing all the data points which have a NA or a null value. Okay, so guys, remember this NA.omit function checks in all the input attributes. Wherever you have a missing or a null value, then it will simply remove that value. So guys, before that, I want to tell you that this Reddit variable basically stores my entire data set. So I've loaded my entire data set into this Reddit variable. And next, what I'm going to do is I'm going to remove all the NA or the null values from my Reddit variable or from my data set. Okay, so let's run this as well. And now let's view our data set. So guys, this is what our data set looks like. Here you can see that there are different attributes of the movies. So there are a lot of details in this data set. Okay, there are a lot of columns. But we'll only be using the Facebook likes for now. Alright, so here you can see actor Facebook likes, cast total Facebook likes. Our demo is only related to the Facebook likes, alright? So we'll be only using those columns. Now here what we're trying to do is we're going to extract only the columns or the attributes which relate to the Facebook likes. Okay, whether it is the director's Facebook likes or the actor's Facebook likes. So these are the columns with respect to the Facebook likes. So we have column number 5, 6, 8, 14, 25 and 28. All of these columns are somehow related to Facebook likes. And what we're going to do is we're going to view the first 50 observations of these columns. Alright, and we're storing this entire thing in a variable called Facebook. Okay, let's run this. Alright, now let's view the Facebook variable. Now you can see that we have only 1, 2, 3, 4, 5, 6 columns. Okay, all of these 6 columns are related to the Facebook likes. You can see it's written director Facebook likes, actor Facebook likes, actor 1, cast Facebook, actor 2 and movie Facebook likes. So guys, I'm viewing only the first 50 observations. Alright, so 1 to 50 it's viewing. Now this particular step, this line over here, it performs the data cleaning. So wherever you find this question mark, it's simply going to replace it by an empty space. Okay, this is what I've mentioned over here, an empty space. So guys, I'm particularly doing this for the attribute called movie title. Alright, so let's run this line. Now next, what I'm doing here is, in this line, since each row represents a movie, let's display the movie name or the titles corresponding to the 6 variables or the Facebook likes. Okay, let me just run this and I'll tell you what it means. I know it's sort of confusing. So now let's view our Facebook variable. So I basically put the name of the movies corresponding to their director Facebook likes and all of these attributes. Okay, so I've just put the name of the movies so that you can understand it clearly. Okay, so the Avatar movie over here has got 0 director Facebook likes. It's got 855 actor 3 Facebook likes and 1000 actor 1 Facebook likes. Okay, this is how it works. Okay, now let's see how key means work. Okay, so I'm just creating another variable here called my data. And I'll explain this in a while. So let's just run this entire thing first and this entire thing as well. So guys, we just ran the K-means algorithm. Okay, so guys, if you see this line over here, what I've done is we've taken this my data and on this we've applied the WSS. Okay, I'll explain this in a bit. And in this for loop, what I'm doing is I'm calculating the value of WSS. Okay, this for loop over here, I'm calculating the value of WSS and then I'm just plotting it. Okay, so just keep in mind that WSS stands for within sum of squares. So guys, this is my plot and this plot is called an elbow curve. Okay, so do you remember that earlier I said that choosing a value for K is a bit difficult. Okay, so the idea behind this plot is to choose the correct value for K. So in this elbow curve, the y-axis represents the distortion. So imagine that you have two clusters and if you take the distance of any two cluster points within a cluster, you'll find that they're very close to each other. Okay, and that's what K-means is all about. Okay, so the data points within a cluster must be very close to each other. But if you take any 2 points which are in two different clusters, so if I have one data point which is in cluster 1 and another data point which is in cluster number 2, and if you compute the distance between these two data points, you'll see that the distance will be more than the distance you'd find between two data points which are within the same cluster. So that's the idea we're going to leverage over here. Now within groups, the sum of squares, which is exactly what's plotted on the y-axis. Now on the x-axis is the number of clusters. So guys, imagine that first there are no clusters. So it means that we have only one cluster, which is the entire data set. So obviously here you can see that for number 1, which is over here, number of clusters equal to 1, the WSS or the within sum of squares value is going to be very, very high. Now in the second iteration, when you split the data set into two clusters, so K is equal to 2, you'll see that the WSS decreases or it drops. Okay, because when you assign centroids and try to cluster the closest data point, the WSS or the distance between the centroid and each data point in the cluster decreases. Okay, so that's why the value of WSS drops. Okay, as the number of cluster increases, the value of WSS will keep dropping because the data points within one cluster will be closer to each other. But now you'd say that why don't we choose the value of K as 14? Because obviously 14 has the lowest WSS, which means that the data points in the cluster are the closest to the centroids. Now we don't choose K as 14 because obviously computing 14 means is going to be very hard. Implementing it will take forever. So in this elbow graph, you have to look for a sharp decline, any sharp decline or an elbow curve, which is where the name comes from. So in our case, you can see that at K is equal to 2, there is a sharp kink or a decline. Okay, this represents the elbow. So after K is equal to 2, the distortion is slowly declining. But at K is equal to 2, there is a sharp drop in the WSS. So this elbow curve shows that for our data set, we must form only two clusters. And forming more than two clusters will not change or affect anything. So the idea is if I have one cluster, my distortion or WSS is going to be very high because all the data points are spread out. Okay, they are out in the space. But the moment you assign two clusters, the distortion drops. So over here, it's clear that I want to fix the value of K to be 2. Now the only thing left to do is call K-means with K value is equal to 2. So let's see how to do that. Now that's exactly what I've done in this line. Okay, I'm running this my data on K value equal to 2. So let's run this line. And if you see the details of this model, widen this. So now let's just interpret this output. Now these are the 6 variables that we chose to detect which movie is more famous. Okay, the 6 variables are director Facebook likes, actor 3 Facebook likes, actor 1 Facebook likes, cast total Facebook likes, actor 2 and movie Facebook likes. And this 1 and 2 represents the 2 clusters. Okay, so this entire first line is the first cluster. Okay, it continues over here. I cannot show it in the same horizontal line for some reason. But yeah, this 1 basically represents the first cluster and this 2 represents the second cluster. So basically this entire first line that you see is collectively the first centroid point of dimension 6. Now let's compare the 2 clusters. So cluster 1 value for director Facebook likes. This is the cluster 1 value for director Facebook likes. It is 606. Okay. But in the cluster 2, it is a contrasting value of 2285 likes. Now similarly, if you compare this to the other attributes as well, Here you can see that for the after 3 Facebook likes, in the first cluster, the value is 1491. In the second cluster, it is 7475. Okay, which is a lot. There's a lot of difference between cluster 1 and cluster 2. So basically, if you compare the values of cluster 1 and cluster 2, you'll see that they have a consistency. Okay, so the likes are much higher in cluster number 2 when compared to cluster number 1. So basically, cluster number 1 represents average or not so famous movies, and cluster number 2 represents most liked and popular movies based on Facebook likes. Okay, so here you can see this is the name of the movie and this shows which cluster it belongs to. Okay, cluster number 1 or cluster number 2. Okay, so on. This is each movie is showing the cluster. So what would happen if we created more than 2 clusters for this particular use case? Okay, if we did that, we'd get movies based on low likes, medium likes, high likes, and so on. So there wouldn't be any clear distinction between the most liked movies and the average rated movies. So guys, with this we come to the end of today's demo. Alright, so we saw how k-means can be used to cluster movies based on their Facebook likes. Okay, so we formed 2 clusters. Cluster 1 had movies with average ratings, and cluster 2 had movies with popular ratings or good ratings. So guys, in today's session, we saw the skills that are needed to become a data scientist. We also saw how important data science is in today's world. So before we go any further, I would recommend you take up the data science certification training offered by Edureka. So at Edureka, we provide a data science certification training which is designed by industry experts to make you a certified data scientist. So before we discuss the certification program, let's see why you should go for the training. So guys, by the end of this course, you will master skills like data extraction, wrangling, machine learning, and etc. And on completion of this course, you'll be offered a data science certificate with your name on it. So guys, what are you waiting for? This course offers everything that is there to know about data science in R. So those of you who are interested, leave your email IDs in the comment section and we'll get back to you with the details at the earliest. So guys, thank you so much for joining me in today's session. Have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!